So I'm going to start recording here. The product of powers property is if we take a to the m times a to the n. Okay, so we're taking two things that have the exact same base. They're both base a, and then they have different exponents, m and n. And we could technically rewrite that as m plus n. That's what product of powers property looks like. I don't expect you guys to have these power properties memorized, but we do need to know how these properties work. That's really important. Okay. So a good example of this would be something like if I had 5 to the third power times 5 to the, we'll just say negative first power. And essentially I would have to add these two things, these two exponents together. So I'd say 5 and then 3 plus negative 1. And 3 plus negative 1 is really like 3 minus 1, so it's really like 5 squared. So that would be an example of product of powers property. You'd get 5 squared, which is 25. But you just add the two exponents together. That's what product of powers is all about. Okay. Next up, power of a power property. This one looks a little bit different. This one would be like if we had a to the m, and then parentheses, and then n power outside. And in this situation, it's almost like a distributive property to get rid of those parentheses. You would say that's the same as a base a of m times n. You just multiply the two exponents to each other. So we could technically say like 3 squared and then cubed. That's the same as like 3 of 2 times 3 power, which is 3 to the 6th power. Okay, that's kind of what this one would look like. Okay, so you can multiply exponents as well. This is all assuming that you have the exact same base. That's the most important part of this. And we get 729. All right. Okay, there's a third one called power of a product, and that's basically if we have two numbers that are being multiplied by each other. Like let's say a times b to the m power, and then you could rewrite that as a to the m times b to the m. You would square, or you would raise both numbers to that same power. That's the idea with this one. So you might have something like 2 times 3 to the 4th power. And you can rewrite that as 2 to the 4th power times 3 to the 4th power, which 2 to the 4th is 8, 3 to the 4th is 81, and I'm not smart enough to do that in my head, so 81 times 8 is 648, is that right? Yeah. Wait, 3 to the 4th is, yeah. No, 2 to the 4th is 16, sorry. So this comes out to 1296. That makes more sense to me. All right, so that covers the first three options: product of powers, power of power, power of a product. I don't expect you to know those names, but that's just what they're called. What I want you to know is how to use each property. That's the key. Another one called negative exponent. That's if I would say a to the negative m power, which I did an example already with product of powers. I have 5 to the negative 1. It is possible sometimes we have a negative number for an exponent. And you can actually rewrite that by flipping the fraction over. It's the same as 1 over a to the positive m power. And we don't like negative exponents. Whenever we have negative exponents, we want to make them positive exponents. And the key to making positive exponents is literally if a number is in the bottom of a fraction, you move it to the top and make it positive. If a negative exponent's in the top fraction, you move it to the bottom and make it positive. That's the key for negative exponents. And the only rule here is also that we have to say a cannot equal 0. Anyone know why I don't want the value a to equal 0? What would that make the denominator in this problem?
1/0.
Exactly, it makes it 1/0, and that's undefined. We can't divide by 0, so that's why a cannot be 0. That's one of the rules we have here. Okay, a good example of like a negative exponent would be if we did, let's say, 7 to the negative 2 power. Well, it's the same as 1/7 squared. So you just make it a denominator, and then we're still squaring 7. 7 squared is 49, but because it's 1/, this is just 1/49. That's what this one would look like. Then we have 0 exponent, and that's just if you have a to the 0 power, it equals 1. Anything raised to the 0 power is always going to equal 1. If you forget that rule, you can always put it in your calculator. But anything raised to the 0 power is 1. And this is another one where it's just going to say, well, a can't equal 0 in this case because you can't have 0 to the 0 power. Okay. Okay, so that's it for that one. Oh, and then it doesn't matter what number I use. So I could just say negative 89 to the 0 power. That equals 1. Okay, the last two properties, they're going to kind of complement the first couple properties. So quotient of powers is going to be like the product of powers, kind of. We're going to say a to the m over a to the n power. And it's going to look very similar to our first problem, the product of powers. When we have the same base and we're multiplying those two bases, we add the exponents. So this time, same base, but we're dividing the two. What do you think we're going to do with the exponents this time? So last time we added the exponents. This time we're going to subtract them. Exactly, you guys got it. So we'd say m minus n. That's our subtraction problem. So if I did a quotient of powers example, I could say, we'll say 6 squared over, actually we'll say, we'll do 6 to the 4th over 6 squared, something weird like that. And we can rewrite that as 6 to the 4 minus 2, which is 6 squared. And then 6 squared is 36. But yeah, just like the product of powers, this one would be a subtraction problem. Okay, the last one, power of a quotient, that's if we have something like a divided by b to the m power. We can rewrite that as a to the m over b to the m. So I did that in green, so that way the green ones match up, and I did the other one in blue, so that way the blue ones match up. So you can see which ones are kind of related to each other. And this one has to be assuming that b does not equal 0. Because again, we don't want the denominator to equal 0. And technically, I guess, in the blue one above, I did forget to mention that we don't want a to equal 0 on that one. All right, last example, we could just say 4 over 7 squared. And essentially you square the 4, you square the 7 separately. 4 squared is 16, 7 squared is 49, and you get 16/49. That's a good example for that particular problem. Those are the properties. We're going to do some examples today where I'm just going to say, go ahead and work on this problem and then list the property. I'm never going to ask you to do it again after today. But today I've asked you just to say, hey, here are the properties, let's practice them a little bit. But you don't need to know the names of the properties after today at all. Just how to use them, which is all this part right here. Okay. Before we move on, just what do the A is not equal 0 and B not equal 0 statements, why do they exist in the last four properties? And we did mention that. We just said you cannot have 0 in a denominator. A denominator of a fraction. That's always a big no-no. So the bottom of the fraction. And then we also have the 0 exponent. You can't have a 0 in the base of an exponent. Yeah. All right, but just because you can't do 0 to the 0 power and get 1, that doesn't really make sense mathematically, so that's just a rule. That's kind of what's going on there. Okay. Another important thing to note here, just a way to avoid errors, when we do multiply powers, do not multiply the bases. That's really, really important. And what I mean by that is if we had something like 3 squared and 3 to the 5th, we would add those together, but we don't want to multiply 3 times 3 and get 9 to the 7th. That would be the wrong answer. It would be 3 to the 7th. So do not multiply the bases. That's very, very important when we're doing these types of problems. Okay. All right, let's take a look at the first couple examples here. I have this -4 times 2 to the 5th and then squared. So because I have the parentheses here with the 2 outside the parentheses, this is almost like I think of it as like a distributive property kind of for exponents. I could technically write this as -4 squared times 2 to the 5 times 2. And then -4 squared, negative times negative is a positive. 4 times 4 is 16. And then this is 2 to the 10th. 16 times 2 to the 10th. And then I could just put that in my calculator. Figure out what 2 to the 10th is, multiply that by 16. And I end up getting 16,384. But the key for this problem is you distribute that 2, and you got to be really careful with -4. And the reason I say you got to be careful with -4. All right, so for part B, what we're going to do is we are going to, all right, so what we're going to do here for part B is we're going to start by multiplying this -1 to both values. It's like a distributive property again. We get 5 times -1, and then we get 11 to the 8th times -1. And this ends up giving us 11 to the -5th over 11 to the -8th. And to get rid of those negatives, we have to flip them over. So it becomes 11 to the 8th over 11 to the 5th. And now the last step is going to be using the property to subtract those two exponents. 11 to the 8 minus 5 equals 11 to the 3rd. And when we get 11 to the 3rd power, that comes out to a big number in scientific notation. 1.37 times 10 to the 6th. And what scientific notation is, we can say a number expressed in scientific notation all right, that's where we have something that looks like c times n, or I'm sorry, times 10 to the n, where 1 is less than or equal to c is less than 10, and n is an integer value. And what scientific notation does is that allows us to write down really big numbers or really small numbers with this times 10 to the certain power. So for example, if we had, in example 2, we have 85 million locusts, and we want to rewrite that in scientific notation, we have to imagine that there's a decimal right here at the end of 85 million. And I want to rewrite in scientific notation, this has to be 8.5. It's going to be a number between 1 and 10. That's what C is right up here, according to this. A number between 1 and 10. So that's what 8.5 represents. In order to get 8.5, though, I have to move the decimal. 1, 2, 3, 4, 5, 6, 7 places. And that's how I'd write this in scientific notation. Moving that decimal 7 places gives me scientific notation now. For this particular problem, it says I'm going to take 85 million locusts per square kilometer, and the area is 1,200 square kilometers. So I'm really multiplying 85 million times 1,200, and that's going to give me a big number. And it ends up being 1.02, and my calculator says E11, and that E is just, again, that's just code for 10 to the 11th. So I can really write this as 1.02 times 10 to the 11th, and that 10 to the 11th is the same thing as E11 over here. That's what's happening. Okay, that covers that particular problem. Now I'm going to give you guys time to work on guided practice 1 through 4. I'm just going to put the answers up, and I'm going to give you guys time to work on the rest of the assignment. I'm just going to put the answers up for everything else today. All right, thanks so much. All right, let's go ahead and check our work. So problem 1, you just do 4 to the 2 times 3 power. It's almost like a distributive property problem. And we end up getting 4 to the 6th, or 4,096. Problem 2, we have to imagine that there's a 1 above that first negative 8. So it becomes negative 8 to the 4th power, or 4,096. When we get down to problems 3 and 4, problem 3, we would distribute the 3 and get 2 to the 3rd over 9 to the 3rd. Problem 4, we're going to get some scientific notation thing. We got to first flip the 10 to the negative 4th down to the denominator of the fraction from the numerator. And then we get 10 to the 7th and 10 to the 4th becomes 10 to the 11th. 6/9 actually simplifies to 2/3. That's where this 2/3 came from over here. And then we just have to put that in our calculator, make sure we're careful with parentheses, and we end up getting 6.67 times 10 to the negative 12th in scientific notation. When we're simplifying expressions, it's really important that we end up with only positive exponents. Very important that we end up with positive exponents only. That's kind of key. We don't like negative exponents. We want to get rid of them. One thing that we want to show is that we can expand it out, and we should get the exact same answer, like 4 squared, and then to the 3rd power, we'd just be writing that 4 squared down 3 times. Writing down 4 squared, we just write that as 4 times 4. So we end up with 1, 2, 3, 4, 5, 6 4s. We'd end up with the exact same thing we did for problem 1. For problem 2, we had a negative 8, and then we had 3 more negative 8s, and that gives us 4 negative 8s. And for problem 3, we could write 2 9ths down 3 times. And we have 3 2s and 3 9s. So expanding it out would get you the exact same answers. Doesn't matter which method you use. It's really up to you. Okay, last 4 problems here. We're going to start with order of operations. And we start with b to the negative 4th, b to the 6th, b to the 7th. I say follow order of operations if you can, but sometimes it might be easier to deal with things outside the parentheses. I think example B is a great example of one where we're going to do inside the parentheses. But let's start with example A. All right, this is b to the 6th, b to the 7th. Get rid of that negative exponent right away, b to the 4th. And then b to the 6th and b to the 7th, I can add those together. And I end up getting b to the 13th over b to the 4th. And then I can do b to the 13th minus 4, and I end up getting b to the 9th. So for problem B here, start with inside the parentheses. I can rewrite r to the negative 2 as r to the positive 2 in the denominator. And then, because I have a negative exponent outside, I could technically rewrite this as to the positive 3. Just flip the entire fraction and rewrite it as positive 3. And I think that makes this problem a little easier for me, because now I don't really have to worry about that denominator anymore. And I'm just going to do r 2 times 3, s of 3 times 3, and I end up getting r to the 6th, s to the 9th. That would be my answer for problem B. For problem C, I have some n to the negative 5s. I'm going to automatically flip those to their other sides, respectively. Notice the 2 is raised to the first power. It is not raised to the negative 5th power. That's a common mistake to want to bring the 2 to the numerator, but we don't want to do that. Okay? For this one, m to the 5, we can write as 5 minus 5. And we end up getting n to the 0 power, which we talked about already. Anything to the 0 power is just going to be 1. So we're left with 16m to the 4th over 2. And then we could simplify 16 divided by 2. That's going to be 8. So this simplifies all the way to 8m to the 4th. And what we'll notice is, if we're lucky on these problems, we might notice, hey, there's going to be an n to the 5th here, n to the 5th there, and we can just divide it out. We don't need to do all these steps that show, oh, first we're going to get n to the 5 minus 5, and then we're going to get n to the 0. We don't need to show those steps once we recognize this. We can just go ahead and divide them out and say, okay, these things are going to become a 1. And we'll see this most again in the last example, example D. So first, this time I'm going to distribute the 2. I'm going to get x to the negative 6th, y to the positive 6th, over x to the 5th, y to the 6th. And this is an example where, hey, look, there's a y to the 6th, y to the 6th. I'm just going to get rid of those right now. And I'm left with x to the negative 6th over x to the 5th. Those become just a 1, so we don't need to write them. And then I can rewrite this as 1 over x to the 6th times x to the 5th. And x to the 6th and x to the 5th is going to become x to the 11th. So I'm going to get 1 over x to the 11th, and that would be my simplified result for problem D. All right, I'm going to give you guys some time to work on the next 4. Get going. I'll have the answers posted in a second. All right, go ahead and make sure to check your answers on these 4 problems. If you have questions, make sure to hit me up during office hours. Just remember that there's no assignment tonight, but there will be a Wednesday activity tomorrow, so make sure you check in for your Wednesday activity. Have a great day, you guys.